Hey students, since today's problem is somewhat complicated, so the problem itself may not be complicated, but you have to implement it as a class. So I'd like to very quick introduction of today's material, and then take more time for you to solve the problems. Let me share my screen for today's problem. So as you know, we have seen what is a class. So today I want to explain more about operator overloading in Python. So the overloading itself means that you'd like to attribute more functions, so relate more functions to a certain operators. So as you know, the plus sign is an operator, and it is usually used for adding two numbers, okay? But if you define a class which is different than numbers such as integer or floating point number, you may attribute, you may associate another function to the operator plus. So how to do that? Make a special, define a special function, special method, which is also called dunder method. So why it is called dunder? Dunder is a shorthand of double under. So you know that those methods starting from double underscore and name and ending with double underscore. For example, plus, for plus you should define double underscore add double underscore. For subtraction, you have to define dunder sub. For the times, you have to define dunder mul. For divide, you have to define dunder true div. So you can define those methods in order to overload those operators. If you define the following point class, for example, you may add 2 points using the operator plus. So actually this point is a two-dimensional point. So it has a single point has two coordinates. One is x, the other is y. So you can initialize those fields of self, and you can add two numbers. So you can make a representation for it. So let me show this code in step-by-step manner in your Visual Studio Code. So you can define a class point, and first of all, you may just type pass, which is just skeleton of point. Okay, so if name is equal to main, then you'd like to create a point P. So print P may be executed. So let me try this again. This is much more like an, sorry. So let me change the compiler for this one. Cancel, executing this again. Okay, can you see that the point is printed here? Double underscore main, that point object at certain address. Okay, address is printed in hexadecimal number. Okay, so this is very ugly printout. So if you want to make a pretty point, then you may define what is a good name. You can define the representation RPR with self, sorry, not self, self. And you can return a format string point of this. So the format string is not needed for this. Okay, and then You may save this and running this. Then the point is very clear, okay? Very pretty one, okay? So if you want to add some coordinates to the point, that should be initialized using init method. Okay, so the init method is accepting two parameters, x and y, and self.x may be assigned by x, self.y may be assigned by y, and your point should reflect the value of x and y. So those x and y may be referenced by the fields of self.x and self.y. Okay, so I added two fields. One is x, the other is y, and those x and y is initialized using your construct x and y. So this is invalid because your point now should accept x and y as a parameter. So let me give the parameters 2 and 3. Save this and running this. And then pointer 2, 3 is printed. Okay? So you can also make another special method. If you want to define str, srt is a train name, str itself, then you may make a more pretty point notation, just the coordinates. Okay, so you can safely copy all those fields from this point. Then, if two string methods are defined, okay, and you'd like to print some of them using these, using RPR and str, but you'd like to print a point using print function, then str is used instead. So RPR is for canonical representation, and str is for a good, pretty printing. So this is for pretty printing, but this RPR is a canonical representation. So I'll tell you what is the difference, okay? So when you make a print, so you'd like to execute this, then str is used instead, okay? So can you see this is used instead rather than point to something, okay? So what is the difference? When you print a string, so you'd like to make a string representation of P, and you may assign this as P string, PSTR. So paste this and print PSTR, so you have to indent this. Okay, so let me just execute this again. So they have a same representation. So let's call it explicitly p.rpr. Okay. Then you know that they should be different. So the difference is that the RPR returns a canonical representation which is used for constructing the object. So if you have a RPR representation, you may evaluate. So you may make another point by eval of P string. So eval means converting a string to evaluate a certain object. Okay, so if you want to print Q again, then it should be the same string to P. Okay, so let me just execute this again. Can you see they are the same? So the point Q is actually evaluated from the canonical representation. Okay, that is the difference. So you may set, how can I check those? You may set x as your another method, new x, and then self.x is changed by this new x. So let's just check that you are getting a pointer P. Okay, so you are creating a new pointer Q. So Q.setX. Okay, so did I set it? So it is not needed to be done there. So setX, okay, Q.setX, and you can change it is 5. Okay, and then it is, you can check that Q is really a pointer object using this. So actually the first field is changed. Okay, so can you see the difference? STL is just for pretty printing, but REPR is for construct, can be used to construct an object. Okay, anyway, I'd like to define add method. So you'd like to define add method in the middle of the method list. So add, then you can define P and Q, and your new point R may be created point P.x plus Q.x. So they are, the 2 points are added by field wise, P.y plus Q.y, and that R may be returned. Okay, then you'd like to print P plus Q. Okay, running this, and 7.6 is printed. Okay, so you can print them in a pretty style. So with the format string F P plus Q equals P plus Q. Then from at this point, your method add is invoked. Okay, for these 2 points, your method str is invoked. Okay, so save this and running this. 2.3 plus 5.3 equals 7.6. Okay, so you can do that as you can just notice that you are using the point as a normal data type. Okay, so you want to print it in a pretty style, and you just create it using a constructor, and you may add some operators. Okay, so that is a very good point of these things. So can you see that this def has some problem? Okay, so the problem is saying that method should have self as the first argument by PyLint. Okay, so it is not, it may not be mandatory. As you can see, it is still in executing. But as you know, those method is starting with self parameter. So the good thing is that you have to rename this as self. Okay, so let me try rename. What is rename refactoring? So it is not installed. So let me try this again. Save this. And I want to rename the symbol self. Okay, so the P is changing now itself, saving this, and the warning is disappeared. Okay. So you can also define subtraction. So why not writing this? So R is created here and just used, and there's no elsewhere using R. So you can safely inline this. So let me just check there's inline something. There's no, it seems there's no inline. So you can safely just make this as return. Okay. So this is not needed. So it is converted as one-liner. Okay. So you can safely add some subtract df sub self.q, self comma q, return point, new point of self.x minus q.x, self.y minus q.y. Okay, so once you define sub, then you may define subtraction. So in this case, the q is much greater than p. So let's copy of this. Print q minus p equals q minus p here. Q minus p. Saving this and running this. So plus should be changed. So this is printed as is, okay. So 5.3 minus 2.3 equals 3.0, okay? So you can also define other operators. So do you have any questions up here? No questions? Okay. Then let me describe today's problem. The problem itself is very simple. Think of that you are given two polynomials, say fx equals x squared minus 4x plus 6, and gx equals 2x cubed plus x. Adding two polynomials is easier than multiplying. For example, adding them results in fx plus gx equals 2x cubed, and there's no cube term here, so 2x cubed, and x cubed, x squared, there's no x squared term in gx, so x squared, and you know that there is x term minus 4x, and there's another x term in gx, x, so summing up them, minus 3x, okay? And there's no constant term in gx, you know that constant is just added up. So the result is 2x cubed plus x squared minus 3x plus 6. So given two polynomials, compute the addition result of them. The coefficients an of the polynomials from an, a sub n minus 1, a sub 1, a sub 0 can be given as input. Note that you have to consider the coefficients even though they are zeros. For instance, polynomial 2x cubed has 4 coefficients. The highest one is 2, and for the square term 0, x term 0, constant term 0. Okay, so in the first line of the standard input, the coefficients of the first polynomial is given. So sorry, the coefficients of them are given, separated by a space. In the second line, those of the second. So you can change this as the first polynomial. So your program should print the sum of the polynomials. So you have to add the s here in the pretty style. So the pretty style is the major concern of today. In the pretty style, the exponent should be printed after the caret. That means x squared should be printed x caret 2. Okay, so x caret 2 means x squared. So x cubed, x carry 3. The pretty style should not contain the term of 0 coefficients. So for the 0 coefficients, you have to neglect those terms. And should not print the coefficients 1 except the constant term. So one means is that if you have here x squared, then it should not be printed 1x squared. Okay, so just x squared. But in the constant term, you know that there's no x in the constant term. So rather than x0, you should print just constant. Also, the negative coefficients, this is somewhat tricky, should be printed as a subtracted term except for that of the term of highest degree. So for example, in the middle of this, you know that the representation of the summation, it should be 2, 1, minus 3, 6. Okay, rather than print x squared plus minus 3x, you should remove plus and minus as the operator. Okay, so let me show you the example using my PowerPoint slide. Okay, so for using my PowerPoint slide, sharing this. How can I do that? Okay. So can you see that there's a polynomial? If the polynomial hx, hx may be 2x cubed plus x squared minus 3x plus 6. Okay, you know that this is the result of the summation. Then internally, you are maintaining the coefficients. The coefficients should be a list of 2, 1, minus 3, 6. Okay, in kind of a list. Okay, but you don't have to print them. So in pretty print, ugly print, in an ugly print, you may print them using, how can you do that? 2x cubed plus 1x squared plus minus 3x, sorry, plus 6. This may be your ugly print. Okay, this may be your ugly print. So in ugly print, you may have in this style. Okay, but this is not allowed in pretty print. In pretty print, 2x cubed is normally printed, but this one should be removed. Okay, 2. And this minus should be represented as minus. Okay, and 3x. And this is not needed for the x term. Plus 6. Okay, so can you get what is the pretty print? So this is pretty print. Okay, this is an ugly print. This may be the internal representation, and this may be the polynomial. Okay, so the polynomial may be here. Your internal representation may be here. Maybe here using What is a good style? Consolas, Fourier, consolas. Okay. And this is an ugly print, maybe ugly print. And this is a pretty print. Okay. How about here? If you have a -2, then you need a minus in the middle of them, but that should be printed here rather than the operator plus. Okay. So ugly print maybe like this, but pretty print, you need this kind of thing. Okay. So let's go back to the original description of problem. Okay. So you can take a look of the details of pretty print here. Okay. There should be no spaces between the coefficients and variable x. Okay, so there's no space to no space x. Okay, but the terms should be separated by the addition or the subtraction operator. They need a space here around the operator. Space, operator, space. Space, operator, space. Space, operator, space. Okay. So additional requirements, you should define and use the class representing a polynomial. You have to overload the add operator. So if your input, this is just an example case, okay, then your output should be 2x carried 3 space plus space 2, x carried 2 space minus space 3x, 3x, no carry here, space plus space 6. Okay. How about the second case? Minus 2x cubed, there's no other terms, but it is represented 0, 0, 0. And this means x plus 1. Okay. Then your output should be minus x cubed. So minus 2x carried 3 space plus space x space plus space 1, which is a constant. Okay. So do you have any questions on the problem?